Hello and welcome to this tutorial on your Arduino hardware. What we're going to do is take a look at an Arduino board and we're going to look at all the stuff that's on it. We're going to talk about what it is and how you use it. So there's lots of little things on there. We're not going to get into all that stuff. It's just going to be a pretty general overview. So just as a baseline here, you'll see I have an Arduino made by Arduino. So if you don't know, Arduino is open source hardware, which means that all of the design files for this board have been made public. So anybody can go and make clones of the Arduino, and lots of people have gone and made clones of the Arduino and sold them. And lots of the clones are really good, and that's kind of the whole idea of open source hardware, is that you're opening stuff up so people can share. But for the sake of for this tutorial series, I would highly recommend getting your hands on an actual original Arduino. And the reason I say that is because it ensures that we'll all be on the same page as we go through. Okay, so enough about that. Let's go ahead and jump in and look at the different things on this Arduino. So first thing we're going to talk about are the digital pin headers. So that's that plastic line that's got a bunch of holes in it and there's a bunch of numbers next to it. And they're numbered from 0 up to 13 from right to left. And so there's actually 14 little holes there that are numbered, and those give you access to the pins on that chip right there. And what those pins allow you to do, they can either act as inputs, so they can read levels of voltage from something, or they can act as outputs, so they could apply like 5 volts, or they could apply 0 volts. So now, digital pins 3, 5, 6, 9, 10, and 11, they can use pulse width modulation, which basically means they can adjust the amount of voltage they apply between 0 and 5 volts. So with these pins, you can like stick in resistors into those holes, or you can stick LEDs into those holes, and it makes an electrical contact with the electrical component. So it basically connects the component to that Atmel chip right there. And that's how you make your connections. So the next thing I want to talk about are pins 0 and 1, and I want to talk about them specifically because you'll notice they have a TX and an RX. So that stands for transmit and receive. Now, when you're talking with your computer or with another device with your Arduino, it's going to be these pins that are being utilized. Generally, if you're going to do a lot of communications, it's called serial communications, with your Arduino on a certain project, probably better off not using those transmit and receive pins too much because it might affect how your program operates. Now, to go along with the transmit and receive pins, there's also transmit and receive LEDs that are embedded on the board. So these lights will blink anytime you're sending or receiving data. So you'll notice when you load a sketch, so when we load a program onto this board, those will blink, and anytime, like I said, you're sending information to or back from the Arduino, those will blink. What they're really good for sometimes is troubleshooting, because if you think your Arduino should be transmitting information and those lights aren't blinking, then you can be pretty sure you're not transmitting information. And if you think you're sending information to your Arduino board, but that receive light isn't blinking, then, well, you're probably not sending anything. All right, so the next thing I want to talk about are the analog pin headers, and they're marked 0 to 5 from left to right, so there's 6 analog pins. And what the analog pins give you access to is a thing called an analog to digital converter, and it's on this microcontroller. And what an analog to digital converter allows you to do is take analog signals and convert them into digital signals. So like, let's say you have a volume knob, and you turn the volume from 0 all the way up to like 10. Or maybe you turn it from 0 to 11. Let's say 11 is the maximum. In there is an infinite number of settings that you could have. So let's say you turn it up just a little bit. Well, now you turn it up to like 1.1. And let's say you turn it a little more, you turn it to 1.12, then 1.13. And the point is that there are an infinite number of turns that you could get on that volume knob in theory. But that infinity does not work digitally. We need to have steps if we're going to work digitally. So what that analog to digital converter does is it takes that infinite amount of variation in an analog signal and it digitizes it into small steps. A lot of sensors you're going to use will give you analog information, so that's going to be really useful. It's also important to note that those analog pins could be used just like the digital pin headers that we talked about before, so it's kind of your decision how you want to use them. Now here's another row of headers, and there's a lot of different things on here. So the first thing we'll look at is the ones with the V. So there's a 3V3, so that stands for 3.3 volts, and then there's a 5V, that stands for 5 volts. Now if you have your Arduino connected to either a power supply, like a battery power supply, or you have it hooked up to your computer with a USB port, with a USB cable rather, you can get 5 volts or 3.3 volts respectively from those pins. So what do I mean you can get? If you attach a wire into that 5 volt hole right there, so if you stick a little wire down in there and you take a multimeter and you measure the end of that wire, there'd be 5 volts there. Similar to the 3.3 volt. You stick a little wire in there, you measure it, it's going to be 3.3 volts coming out of that header pin. We'll be using the 5 volt pin rather frequently for all of the sketches, and you'll see how. Now let's take a look at the reset button on the Arduino board. It's pretty straightforward. When you press that button, the Arduino is just going to start over at the beginning of the program. So it's not going to erase anything off the board. All it's going to do is sort of kind of reboot. But it does it super quick. I mean, pretty much instantly. Now there's also a reset pin right down there by the 3.3 and 5 volt pin headers. If you apply 0 volts to that pin, then you can reset the board also. So that's another way to reset the board, and don't use it too often, but it could definitely be helpful. Now let's talk about the ground pins on the Arduino. There are 3 ground pins. There's 2 on the bottom next to the 3.3 and 5 volt pin headers, and then there's one on the top, and that's next to digital pin 13. Now the ground pin gives you access to the lowest voltage on the board. I'm not going to get into the electronics of that right now. We'll talk a lot about it later, but just want you to know we'll be using the ground pins in just about every sketch that we work with. There's also a power on LED. So this light is on when you have the power applied to your Arduino board, either through a USB to a computer or with an external battery power connected. And finally, if you do have an external battery connected, you'll see it's this port here is where you would connect that battery pack. So that's pretty much it for an Arduino board overview. Again, there's a lot of other stuff on here, and you might be wondering what some of that stuff is, but to be honest, if you're just getting started, you're probably not going to use a lot of that, so I wouldn't learn it till you need to know it. Thanks so much for listening in. I look forward to seeing you at the next tutorial where we're going to start talking about the Arduino Integrated Development Environment. See you then.